Hi everybody. In this video, we're going to talk about solving equations through graphing. So let's read this over here. When two equations are graphed, any point which is on one line but not the other is a solution to that line's corresponding equation but not the other equation. Any point which is not on either line is not a solution to either equation. And the point of intersection, that's where the two lines meet, is a solution to both equations. So let's go ahead and graph these equations over here. We could solve these by using the substitution method. So for example, I could say, well, if I know from equation A that y is equal to 5/2 x minus 6, what I could do is I could take this expression and plug it in for y over here, and then I could write 5/2 x minus 6 equals 8 minus x, and then I could go ahead and solve that equation for x, and then whatever I get for x, I could plug it back into either one of these equations to figure out what y is. So that's one way of solving this, but in this video we're going to talk about solving the system of equations by graphing. So let's review an easy way to graph these equations. So I have these equations already in slope-intercept form. So the y is already by itself. And that means that whatever number is next to x is the slope. So for example, in this equation, 5/2 is next to x. And so 5/2 is the slope, and 5 would be the rise, 2 would be the run. And then I have over here minus 6, which means that the y-intercept is 0, -6. So what we're going to do first is we're going to plot the y-intercept for equation A. I might have to make this a little bit smaller, actually. I hope that's not too hard to see. All right, so the y-intercept for equation A would be 0, -6. So 0 on x, -6 on y. So that's one point that's going to be on our line. And then to find another point, we'll use the rise and the run. So the rise is 5, which means that from here I'll go up 5 spaces. 1, 2, 3, 4, 5. And then from here I'll go over 2 spaces. So both of these were positive. So positive in the vertical direction is up. That's why I just went up 5. Positive in the horizontal direction is to the right. So that's why I'm now going to go to the right 2. So from here, 1, 2. And then this is going to be another point on the line. And really all you need to make a line is 2 points, right? So I could draw a line through these points right now, and that would be my line. But since I'm doing this by hand and I want to be pretty accurate, I know that if I just try drawing a line like that, my handwriting is not very good. I'm just going to draw a couple more points here. So let's see, I'm always going to go up 5, 1, 2, 3, 4, 5, and then to the right 2, 1, 2, so that would be another point. And then again, 1, 2, 3, 4, 5, and then to the right 2, so that would be another point. Okay, so maybe I can, and then if I wanted to go backwards, I would go to the left 2, and then down 5. 1, 2, 3, 4, 5, so that could also be another point. All right, and then let's just draw a line through all these points. I'm going to do my best to make it straight. I know I'm not going to be able to, but I'll try. What happened? Wait, what happened over there? That one looks really bad. I'm supposed to go to the right 2. 1, 2. Okay, so there's another point. Ah. All right, so there's my line. Okay, now let's do the other one. Remember, it's the number which is, it's not just the first number is the slope. That's not correct. It's the number that's next to x is the slope. So over here, the number that is next to x, it's not written explicitly. So minus x is the same as minus 1x. Okay, so the slope would be -1. And just to break it up into a rise and a run, we could put this 1 over 1. Because 1 over 1 is the same as 1, right? Just like 2 over 1 is the same as 2, and so on. So for this one, I know that my y-intercept is going to be 0, 8, since this is the number which is not next to x. So 0, 8 will be over here. And then for my rise and my run, so the rise is going to be -1 and the run is 1. So that means I'm going to go down 1 and then to the right 1 to find another point. And then again, down 1 to the right 1 to find another point, and so on. And this one is going to look like this. Okay, and then if I wanted to go backwards, I would go to the left 1 and then up 1, sort of the opposite of what I was doing before. Okay, that would be a point, this would be another point, and so on. So I can continue in that direction also. Okay, so now I have 2 lines here, and it's very important that we understand what these lines represent. Every single point that's on this red line is a solution to equation A, and every single point that is on this green line is a solution to equation B. Okay, so let's just verify that. Let's pick a point, let's say this point right over here, which is 2, -1. Okay, that is on the red line. So I should be able to plug in those values, 2 for x and -1 for y, into this equation over here and see that that's a solution to this equation. So x is 2 and y is -1. So I get -1 equals 5/2 times 2 minus 6. So these 2's can cancel out. And I have -1 equals 5 minus 6. And 5 minus 6 is -1. Okay? So I get -1 equals -1. All right, both sides match. So yes, 2 -1, when I plug it in, I can see that this is a solution to equation A. But this point is not on the green line, so it should not be a solution to equation B. And let's just verify that. If I were to take 2 for x and -1 for y and plug it into this B equation, 2 for x, -1 for y, am I going to get a true statement? I get -1 equals 6, which of course is not true. -1 is not equal to 6. So I got a false statement here, which means that this is not a solution to equation B. All right? So going back here, any point which is on one line but not the other is a solution to that line's corresponding equation, but not the other equation. Right? We could do, and by the way, this is not the only point which is a solution to this equation. Any point on this line is a solution to equation A. Any point on the green line is a solution to equation B. And that does not only include the whole number of points. So for example, if I wanted to look at equation B, then this would also be a point on equation B. I could use some decimal values. So this would be 5.5 for x, and it would be 2.5 for y. If I were to plug that in here, so 5.5 for x and 2.5 for y, so I get 2.5 equals 8 minus 5.5. Okay, and 8 minus 5.5 is 2.5. So I get 2.5 on the left and 2.5 on the right, so that's good. All right, so any equation that's on the green line but not the red line is a solution to this equation but not this one. And any point which is on the red line but not the green line is a solution to this equation but not this one. Okay? Now let's look at this sentence over here. Any point which is not on either line is not a solution to either equation. All right, so that makes sense. So for example, what if I were to take, let's say this point over here, how about -6, 3? All right, -6 for x and 3 for y. So that's not on the green line and it's not on the red line, so it should not be a solution to either one of these equations. And let's see, if I plug in -6 for x and 3 for y, okay, let's see, so this would be 5 halves times -6 and then -6. So let's see, -6 divided by 2 is -3, and then -3 times 5 would be -15. So I get -15 over here, so 3 equals -15, then -6, and this is going to give me -21, which of course is no good. The sides don't match. If I do it to this equation over here, -6 for x and 3 for y, then I get, this would actually be minus, and then x is -6, so minus -6, which is the same thing as 8 plus 6, okay, and so I'd get 14 over here, but 3 over here, so that's also no good. 3 is not equal to 14, right? So I could do something like this to say that both sides are not the same, okay? All right, so hopefully that makes sense. And then, finally, we come to the very last sentence of the video, which again should make intuitive sense now. The point of intersection is a solution to both equations, and therefore it's a solution to the system. Okay, so what do we mean by a solution to the system? We just mean a pair of numbers that is a solution to this equation and also this one. So if we look at this point right over here, which is the intersection of the red line and the green line, well, wait a minute. This point over here is on the red line, so it should be a solution to this equation, but it's also on the green line, so it should be a solution to that equation also. All right, and again, let's just verify that. So what is this point over here? That would be 4 for x and 4 for y, okay? So if we plug in 4 for x and 4 for y, 4 divided by 2 is 2, and then 2 times 5 is 10, so we get 4 equals 10 minus 6. 10 minus 6 is 4, so I get 4 equals 4, so that's good. Over here, if I plug in 4 for x and 4 for y, I get 8 minus 4 is 4, so again, I get 4 equals 4, so that works, right? So this point, which is the intersection of both lines, is where the two lines meet. This is a point on the red line, and it's also a point on the green line, and therefore it's a solution to both equations, which means it's a solution to the system of equations. And in fact, it's the only solution to the system, because there's no other point which is on both the red line and the green line. Okay, so there's no other point which solves both of these at the same time. That doesn't mean that there's no other point that solves this one individually or this one individually. We already saw a bunch of examples of that. There, in fact, are an infinite number of solutions to equation A and an infinite number of solutions to equation B. Just look at any point on the red line for equation A or the green line for equation B. But there's only one point that is a solution to both of them, and that's this point over here where the two lines intersect. And therefore, that is the solution to this system of equations. All right, so that's it. Have a great day.